Hey everyone, welcome to our podcast, where we dive into the power of algorithms and how they're shaping the future.
That's right, I'm Juan Ramon Ares Garcia.
And I'm Alan Ignacio Juarez Pacheco. Today we're talking about how deep learning is revolutionizing medical diagnostics, with a special focus on one of the most powerful tools in machine learning, the Adam Optimizer.
Let's start with the big idea. Think about how long it takes radiologists to review thousands of MRE or X-ray scans. It's a huge workload. Not to mention the process is really expensive and subject to human errors.
Exactly, and when you're dealing with critical conditions like breast cancer, Alzheimer, or pneumonia, every second and every accurate diagnosis counts.
That's where deep learning and specifically convolutional neuronal networks come in. These models can be trained to detect abnormalities in medical images with high accuracy, sometimes even outperforming human experts.
But training a neural network isn't easy. You need to optimize its internal parameters, also known as weights, so that it minimizes prediction errors. This process is called training, and it requires optimization algorithms.
One of the first optimization methods ever used is called gradient descent. It's like hiking down a mountain blindfolded. You feel the slope under your feet and take steps in the direction that goes downward.
That works, but it's slow. Worse, sometimes you get stuck in a little ditch. Not the bottom of the valley, just a bump on the side, and you can't get out. That's called a local minimum or a saddle point.
To solve that, researchers came up with more advanced optimizers like ADAM, which stands for Adaptive Moment Estimation.
Adam combines two key ideas: momentum, which helps it keep moving through a small dips instead of getting stuck, and two, adaptive learning rates, meaning it adjusts how big each step is for each parameter.
That's like giving our blindfolded hiker memory of past steps and better shoes. ADAM speed ups training and leads to better models, specifically in complex problems like medical image classifications.
Let's talk about what kind of diseases these systems can help detect. With convolutional neural networks trained using Adam, researchers have developed systems that detect breast cancer in mammograms, lung disease in chest X-rays, brain tumors in MRI scans, and diabetic retinopathy in retinal images.
These models are trained on large datasets like the NIH Chest X-ray dataset or BRAT, which is for brain tumor segmentation.
Sometimes they use ImageNet to pre-train the models, so they already understand basic patterns before focusing on medical features.
Alright, now let's take a deeper look at one of the key researchers articles we found. One of the most impactful ones is titled Dermatologist Level Classification of Skin Cancer with Deep Neuronal Networks, published by Nature.
In this study, researchers at Stanford trained a CNN on over 129,000 images of skin diseases, representing more than 2,000 different conditions. They used a technique called transfer learning, starting with a model pre-trained on ImageNet and then fine-tuning it for skin cancer detection.
The amazing part? The model performed at the same level as professional dermatologists when classifying skin lesions as benign or malignant.
That's huge. Think about remote communities or clinics without access to specialists. This kind of AI system could act as a diagnostic assistant, not replacing doctors, but helping them make faster and more accurate decisions.
And yes, you guessed it. They use Adam as the optimizer without training such a deep and complex network that, in the other hand, it would have been slower and less effective.
To wrap it up, deep learning is reshaping how we think about medical diagnosis, but none of it will be possible without the right optimization algorithms, and Adam is one of the best out there.
As students working on AI and healthcare application, it's exciting to know that the tools we are studying aren't just a theory, they are being used to save lives.
Thanks for listening to this episode. We hope you learned something cool about AI, medical imaging, and the Adam Optimizer.
We are Alan and Ramon, and we will catch you in the next one. Stay curious.